So you've got zero point 0.5 grams of impure ammonium chloride warmed with excess sodium hydroxide to liberate ammonia. As you do more questions, you'll get experience with the kind of words that people use. Mixed or warmed, unless you know specifically that two things don't react, mixing things usually means that it's gonna react together. Here they've given you an equation, so that's even more obvious that there's a reaction happening. Warmed means that the reaction happened at higher temperatures. Liberate ammonia means to free ammonia, but again, generally, if you're gonna get it out, it means that it's a product. Yeah, not something we have to worry about because here the equation's given. So they liberated ammonia. The ammonia that gets liberated then mixes with 25 mils of 0.2 molar sulfuric acid. They've given you the equation for that as well. Again, it's not one of the ones in your Module 3 course, so this one has to be given. The excess sulfuric acid required 5.64 mils of 0.2 molar sodium hydroxide to react. That one, the equation's not given, which makes sense. This is an acid-base reaction that is specified in your Module 3 course. Yeah. What's the percentage of NH4Cl, ammonium chloride, in the original sample? Again, pay attention to the kind of decisions we make and the kind of questions I ask you to lead you to the answer. You might like a different colored pen out. Yeah. Now, you've got a few different ways of starting this question. I can walk you through straight to the answer, but I want to take you through the decision making process with me. Yeah. Tell me, I want you all involved. What do we normally do? Ignore this question. What do you normally do when you've started a calculation question? You've answered this question earlier in class. What do you normally do? You normally start with a balanced chemical equation. Good. When you're struggling in a question and you don't know what to do, you start with a brainstorm. Yeah. So you're right. We've got most of the equations already. Okay. You've got this one. You've got this one. There is one equation missing though. So let's say you're desperate in an exam and you really don't know what to do and how to get to the answer. You want to scrape up as many marks as you can. You get 1 mark for providing some relevant information. Okay. That's the lowest. If you look at the marking criteria on HSC past papers, box 1 for 1 mark is always provide some relevant information. You've got most of the equations. You don't have this one. Okay, so let's walk through the working out afterwards, but I'm desperate for at least my first mark. I'm going to do this one. Yeah, H2SO4. Let's label them carefully so we can refer to them. A difficult question is made worse by how nervous you get in the exam. Yeah, so keep your working out neat and tidy. Give yourself the best chance of getting to the answer. H2SO4 plus NaOH. This is sulfuric acid with sodium hydroxide. What is the name and therefore what is the formula of the salt that gets formed? Exactly. So sodium sulfate, Na2SO4, it's an acid-base neutralization equation. So acid plus base and then the salt plus a water. We don't just want any equation, we want a balanced chemical equation. So I'm going to balance with a 2 on the sodium hydroxide and then a 2 on the water as well. Okay. All right. Follow your standard procedure until something sticks out. So these are your 3 equations. I should put the number 3 down here right next to the equation. What do you normally do after you've gotten the equation? What have you told me before? Step 1, get the equation. Step 2, calculate what? What have you always told me before? Calculate the moles of something. Okay, so let's go and see if we can do that. You don't have to know exactly where to start. Yeah, this is a hard question. We can do a process of elimination. Okay, so I'm going to walk you through it. There's a bunch of different numbers here. Let's see if there's something I can do. 0.5 grams impure ammonium chloride. Read the question carefully. It is not ammonium chloride. It is impure ammonium chloride. Is the entire 0.5 grams ammonium chloride? Yes or no? No, it's not. So therefore, can you do mass on molar mass with it? No, because it's a mixture of a bunch of different things. If you want to use a number, it has to be the number for one chemical exactly. You cannot use the point 0.5. We're not going to start here. Okay, the next number here is 25 mils of zero point 0.2 molar sulfuric acid. Could you technically calculate the moles for that? Yes, you're going to do C is N on V, so N is C times V. Yeah, now I'm going to give you something else. Your purpose for calculating moles is to relate it to the equation and then use the ratio in the equation to relate it to something else, yeah? So I'm going to add something in for you here. What you need isn't just moles. You need the moles that reacted. Yeah? That's why when you get questions, you're always telling me, oh, we have to figure out the limiting reagent because that's the number you can use to relate to something else. Okay. So I want to emphasize with your experience now, you don't just want moles, you want moles that reacts. Okay. So technically speaking, yes, you can calculate moles, 25 mils, zero point 0.2 molar, N is C times V. If it's also the moles that reacts, you can now use this equation. Let's check. Can you please read the third dot point? That 25 mils of zero point 0.2 molar sulfuric acid, does it all react? Does any of the sulfuric acid go on to do anything else? Good, exactly. The question doesn't tell you that ammonia reacted completely with 25 mils of zero point 0.2 molar acid. It just mixed with it. And then what happens after? Excess sulfuric acid that was left over from that reaction went on to react further with sodium hydroxide. Okay, so this, when you do C times V for this number, it is not going to be applied to this equation. You can't, because not all of it reacts, some of it's left over. Okay, so the excess sulfuric acid required 5.64 mils of zero point 0.2 molar sodium hydroxide to react. Now, you can do this by the process of elimination. If you can't use this number, and you can't yet use this number, you just have to use this number. That's the only number left. Otherwise, we have no place to start. Yeah. So you can either do a process of elimination in the exam, but we're going to here talk about why we can use that last number. Okay. Now, guys, pay attention. You can eventually, listen carefully, yeah? You can eventually get to the amount that reacts here. Okay, you can eventually get that. I'm going to let you know what's happening. Okay, second dot point, ammonia mixed with 25 mils of zero point 0.2 molar sulfuric acid. You acknowledged that's not the amount that fully reacts. I get that. That's completely fine. You're correct. Yeah, this isn't the amount that fully reacts, but this is the amount that got added. Okay. It's not the amount that reacts in the second equation, but it is the amount that got added. All right. And then you guys told me that some of the leftover H2SO4 reacts here as well. Okay. So I'm going to be careful with the way I word this. 25 mils of zero point 0.2 molar sulfuric acid got added. There's some sulfuric acid left over. Let's pretend like we know what it is. We'll eventually find it out. All right. Listen carefully. You know the amount of sulfuric acid added to the second reaction. You will eventually know the amount of sulfuric acid left over. You know the amount of sulfuric acid added. I promise you we can calculate the amount of sulfuric acid left over. This is my question. You know the amount added. You will eventually find out the amount left over. How do you calculate the amount that got lost or reacted in reaction two? Ignore the chemistry side of things, yeah? I tell you that you have a certain amount of apples. All right? You close your eyes and then someone does something. You open it back up, you open your eyes back up, and then you can count the amount of apples that you now have. Okay? How can you calculate how much you got lost of the apples while your eyes were closed? How much you had at the start minus how much you have at the end. Exactly. Okay. So when the chemistry gets confusing, take it out of the chemistry context. Half of the time it's just your head playing with you. Yeah. If you know how much sulfuric acid got added, you can figure out the amount left over. The amount added minus the amount left over is going to give you how much got lost in the second reaction. Yeah. So let's make a little bit of a note here. H2SO4 reacted is added, how much you added minus how much gets left over that's able to go somewhere else. Okay, so if you want to use the second equation, that's what you eventually have to do. I don't yet have the amount left over, so I have to find that out first. Yeah. And then again, guys, we said the amount left over reacts here. So that's where we have to start. Okay. If we want to use the second equation, you need to do added minus leftover. Leftover is the amount that reacts in the third point, so we have to start at the third point. Yeah. Okay. Remember again, different colored pen out. Track the thinking that we're doing. You're not going to understand it the first time round. Yeah. If you want the amount of sulfuric acid left over, it reacted with this sodium hydroxide, so we can start there. Moles of sodium hydroxide is C times V. 0.200 molar times 5.64 mils. We're going to turn that into liters. 0.00564 liters. What is the moles of sodium hydroxide, please? Thank you. 0.001128 mole. So that's the moles of sodium hydroxide. It reacts with the H2SO4 that's left over, yeah? Left over from the second reaction. So I want to get to that leftover H2SO4, which means I want to go here. So guys, it's a 1:2 ratio. I'm starting off at the sodium hydroxide and I want to go to the sulfuric acid. I'm going to go from 2 to 1. What do you want me to do to get the moles of sulfuric acid? Divide by 2, good, or times by half. Okay. When you do more complicated questions, your labeling is even more important than usual. Sulfuric acid shows up in two different equations. There's some added, there's some left over, there's some reacted. I need to be careful. Yeah, this is going to be the moles of sulfuric acid left over after the second reaction. You guys told me to divide by 2 or times by half, so we'll do that. Half times the moles of NaOH is half times 0.001128 moles. What is the moles of sulfuric acid left over? 0.000564 mole. Thank you. So that's the amount left over after reaction 2. We said that if you know added and you know amount left over, you can figure out the amount that got lost. So we've got the leftover now. I can calculate the amount added. They have to tell you that. They told me that they mixed it with 25 mils of 0.2 molar. Yeah, so let me calculate that first, and then I can put it into this equation that we've formed. Okay. So moles of, remember any questions as you're going, you let me know. Yeah. Moles of sulfuric acid added in reaction to C times V. They added a 0.2 molar solution and they added 25 mils of that. So that's 0.025 liters. So how many moles did they add in reaction to, please? Point oh oh 5 mole. So I've got both parts of my equation. I've got added, I've got left over. You guys told me if I know the amount added and I know the amount left over, the difference must be the amount that I lost or that I reacted. So now I can do that. Moles of H2SO4 reacted. Because it shows up in two reactions, I have to be careful. This is reacted in reaction 2 is added minus left over. So that's your 0.005 minus 0.000564, both numbers that we've calculated ourselves. So how much did we lose in the actual second reaction? 0.004436 mole. Thank you. Okay, at this point in the question, you might be like, why am I going back to reaction two? Why did I start with reaction three? It's a long question, so we kind of forgot what it's asking us for. Do not continue a question blindfolded. When you go with a long question, you need to go back and remind yourself what it's asking you for. Yeah, so let's go back. Let's clean this up. This is going to sound silly, but I want you guys involved, yeah? What are they asking you for in the question? Where did I put the question mark? What chemical are you trying to get back to? Stay with me. What chemical did they ask you for? The NH4Cl in the original sample. So this, guys, that's the question, but this is the equation and the chemical that they want you to go back to. Yeah? So you need to eventually get back to that chemical. When you're doing a long question, remind yourself of what it's asking you for. You want to go back to the NH4Cl. Okay? You are currently here. All right? I just want to remind you, this is where you're at the moment, and this is where you want to go. If you want to jump between chemicals, you need to go with a chemical that's present in both equations. Yeah? So guys, you're currently here. I'm running out of different colors. You're currently here. You're trying to get back to here. Okay? What chemical are you going to jump to next? You want to get back to the NH4Cl. You're currently at the H2SO4. Good, Hannah. What chemical do you need to go to next? Good, guys. Good. You need to get to the NH3. You need to get here. Okay. First of all, that's because that's what's the question worded out for you in the first place. But even if there wasn't written wording, the NH3 is in both equations. That is the chemical that'll allow you to go back to the first equation. Yeah, so you're currently here. You're trying to get to the NH4Cl, which is related to NH3. The H2SO4 is also related to NH3, so you're trying to go there. Okay, let's clean this up again. All right, you are currently here. You're trying to go back to here, which is what we've said. What do you want me to do to the moles? It's a 1:2 ratio, and you're going to 2. Multiply by 2 this time. Good, because you're starting at 1, you're going to 2 this time. So we want the moles of NH3. Which we saw in the equation earlier is 2 times the moles of H2SO4, 2 times the moles of H2SO4, 2 times 0.004436. What is the moles of NH3, please? 0.008872 mole. Okay, so this is the moles of NH3 that's related to sulfuric acid in the second equation. You're now traumatized from what we've just done. Let's just check that we can jump to the first equation, yeah? And there's no added or leftover thing. Can you have a read of the question again? Is there anything implied in the wording that the amount of ammonia in the second reaction is not the same as the first? Or are we okay to proceed? You can do some kind of process of elimination, even if this wasn't the amount for us to jump back to the first equation, can we do anything else? Is there any other number to work with? No. Okay. They haven't given us anything else about ammonia. All right. So even if we didn't know what to do next, we just, at the very worst, you would have to assume that the amount of ammonia you got came all from the second reaction, yeah, because they haven't given you anything else to work with. So they told you they liberated ammonia and then the ammonia mixed with the sulfuric acid. So because there's no other information to work with, then we do just say all of the ammonia that came from the first reaction must have went to the second. Yeah. So we can jump from here to here straight away. Okay. So this moles of ammonia reacted in reaction 2 is the same as the moles of ammonia that was produced from reaction 1. There's nothing else for us to do besides that, yeah? So we're going to say all of the ammonia we got in the second reaction came straight from the first reaction. There's nothing else that we have to do like this added minus subtracted minus left over anymore. Okay? So this step in the working out hasn't been too long. We still remember what the question asked us for. It's the NH4Cl. We're currently at the NH4. So let's go back. Have a look at the ratio for me. You're currently at the NH4. What do you want to do to get to the NH4Cl? Yeah, there's no numbers in front of it, so the numbers are both 1, which means it's a 1-to-1 ratio. So the answer is nothing. I do nothing. It's the same exact moles. I just have to label my working out carefully. So moles of NH4Cl, it's a 1-to-1 ratio, so it's the same as your moles of NH3, which is your 0.008872 mole. Okay, we are now back at the chemical that the question asked us for. Once you got the chemical and once you've got the moles of that chemical, do whatever they want about it. Read the question again for me. What did they actually want about the NH4Cl? They want the percentage of the NH4Cl in the original sample. Good. Now, percentage is a little bit confusing, yeah? Normally you express percentages in the same unit as the total, yeah? So guys, the original sample, what did they tell you about the original sample? What number, what piece of information did they tell you about the original sample? Because you want your NH4Cl, if you're going to do a percentage, it needs to be in the same units. They said it's impure, yes, any number, and it's 0.5 grams. Good. Guys, what they told you about the sample is that it's 0.5 grams. So my question to you is this: what do you want to do to the moles of NH4Cl that we just got? What unit do you want to turn it into as well? You also want it in grams. Good. The original sample is 0.5 grams. If you're going to express your NH4Cl as a percentage of that 0.5 grams, you should also have your NH4Cl in grams, and therefore we convert it to mass. Okay, so we want the mass of NH4Cl, moles times molar mass, 0.008872 mole, multiplied by, you've got nitrogen, 14.01, you've got 4 hydrogens, 4 by 1.08, and a single chlorine is 35.45. So that's equal to 0.4745 grams. And then if you're going to do percentage, you do smaller number divided by bigger number. And then what do you times it by to turn something into a percentage? The mass was 5. You times it by 100. Yes. Okay, what's our answer? 94.916 percentage. You finally got into the end of the question, so we can round off here. The smallest sig fig they've given you to work with, they're all 3 sig figs, 0.5003, 25.03, 0.2003, and then these ones are 3 sig figs as well. So we're going to round up to 3. You'll get 94.9% to 3